Hi, this is Mr. Erlin walking you through 9.1 Pythagorean Theorem today. In the event that we have a triangle that we know is a right triangle, then what the Pythagorean Theorem says is if there's a right triangle where A and B are the side lengths and C is the hypotenuse, then A squared plus B squared equals C squared. And what that means is we can find a missing leg or a hypotenuse in a right triangle if we're given two of them. So for example, let's say I'm given a picture that tells me that AB is 30 and BC is 12. First of all, I do recommend you draw this picture out and then you take the information and transcribe it. This says A to B, the distance from A to B, is 30. So I'll put a 30 there. This says the distance from B to C is 12. So from B to C, that's 12. What I'm looking to find is the length of AC. A to C. So I'm going to put an X here. I've got two sides and I need a third side. It's a right triangle. This is a perfect example for Pythagorean theorem. The only challenge is which one goes in which of the three spots. I know that opposite the biggest angle, and in a right triangle, the right angle is the biggest angle because it adds up to 180. So if 90 is used up here, there's only 90 left to split between those two to make the total of 180. Therefore, those must be acute angles smaller than 90. So I know the side opposite 90 over here has to be the biggest one. If A were the biggest number, and then I added more onto it, that would make C the biggest number. So that's a conflict. Same with B. That means that the biggest number, the hypotenuse, has to be C, the standalone one over here. So I'm going to put my 30 there. As to what order these go, it doesn't really matter. I'm going to say x squared plus 12 squared. If you were to say 12 squared plus x squared, it wouldn't matter. Now, this is one where it's asking for the length of the leg. This is the setup. And then I'm going to solve it. Can't do anything with x squared. I can square 12 and get 144. I can square 30 and get 900. Squared, of course, means times itself. And then I'm going to solve for x. Right now, what's being done to x? It's being squared, and we're adding 144. In order to undo this thing, we're going to do reverse Pemdas. When you solve a problem, you do reverse Pemdas. So instead of doing multiplication or exponents early on, we're going to get rid of the addition. So the way we undo addition is subtraction. And now we've got x squared equals 756. I don't want x squared, I want just x. So I need to undo what's being done to x. Right now it's being squared. The opposite function of that is the square root. So I'll do it to this side, getting me just x. And when I do it to this side, I also have to do it to this side. So my exact answer is x is equal to the square root of 756. But I'm going to ask for the number rounded nearest 100. So I'm going to say, square root of 756. And that's going to give me that x is approximately equal to 27.495454. But I'm only asked to round it to the nearest 1/100th. That means I only want 2 decimal points. So I don't want all that stuff, but I have to take into account its value. This is closer to the next number up. In other words, because this is 5 something something, it's going to push this number up, which means that 9 gets pushed up to a 10. Which means the 4 gets pushed up to a 5. In other words, this becomes 27.50 when rounded to the nearest 100th. Now again, this is the type of scenario you get when you're missing a side length, a leg, not the hypotenuse. Doing this problem, you're also going to be faced with problems that are asking you to find the hypotenuse. So for instance, say I was given ACB, and I was given that AC is equal to 12 and BC is equal to 18, and I'm looking for AB. Again, I draw the triangle. I put in the values. From A to C is 12. From B to C is 18. And from A to B is what we don't know, so I'll call that my X. This will be my largest value. So this is the one that stands alone. And these two each get squared and then added together or summed. And now I'm going to have to do each of those things squared. 12 squared is 144. 18 squared is 324. And that equals X squared. Adding these together, I get 468 equals X squared. And then I'm going to say, I want X, not X squared. So I have to undo what's being done to both sides. I have to undo this squaring. So I'm going to square root. And if I do it to one side, I do it to the other side. This becomes X. This is exactly now square root of 468. I'm going to apply the symmetric property because I like to see the X on this side. And now I'm going to use my calculator to approximate this. I'm going to say, I want the square root of 468. And that tells me that X is approximately 21.6330765. But again, I'm rounding to the nearest hundredth. So I'm looking at this part after here. Does 3 push me up closer to 0.64, or does it leave me closer to 0.63? Well, this is closer to 0.63. So I'm going to call this X is about 21.63 when rounded to the nearest 1/100th. That's how we apply the Pythagorean theorem.